For blood test number 4 in 2024, when using Dr. Morgan Levine's biological age calculator, PhenoAge, we saw that my biological age was 17 and a half years younger than the chronological. So what may be contributing to these data? In terms of prescription meds, for those who are familiar with the channel, it's not a surprise, but for those who may be new, welcome. I was diagnosed with hypothyroidism in my mid-20s, so I've been taking levothyroxine for about half my life. All right, so that brings us to supplements. The first is also a standard, vitamin D, 1,000 IUs per day in the non-summer months when I'm not able to get full body sun exposure. And note that this is 29 of the 29 days that correspond to this test. In other words, I took it for every day from the last blood test, which was on April 29th, blood test number 3 in 2024, through the day before test number 4 on May 27. So from one blood test to the last, that's the dietary period that corresponds to this test. I also supplemented with branched-chain amino acids, leucine, isoleucine, and valine, 5 grams per day, to test the hypothesis, or to test the correlation, at least in my data, that a relatively higher protein intake is significantly correlated with lower homocysteine. So to more directly test that, I added branched-chain amino acids into the approach, 5 grams per day, for the last 14 days of this period to see if that could lower homocysteine. And unfortunately, it didn't. I may give it its own video, but for now, we know that going high-dose branched-chain amino acids didn't impact homocysteine, at least in my data. And then I usually supplement with nicotinic acid to help keep NAD levels around 40 micromolar, but for this test, it was only one of those 29 days. Now, for the next test, it will be there, and that's only until trigonelline, which is now sold as a supplement, arrives. So I'm going to continue the experiments looking at trigonelline as a potential way to impact NAD, only this time using supplements, as I've pretty much exhausted all dietary means to try to impact NAD through trigonelline. All right, so that's it for supplements. No other purported geoprotectors or senolytics. So that brings us to diet, and more specifically, what diet composition corresponds to this test, where I was 17 and a half years younger relative to the chronological. And that's what we'll see here. And again, these are 29, this is the 29-day average from the last blood test through the day before this test. And for those who are unfamiliar with the approach, I weigh all of my food. I've documented that approach in a recent video, so if you missed it, it'll be in the right corner. So for the first half of the diet, that's what we can see here. This list is ranked in grams from highest to lowest, with the exception of green tea, which is in ounces. And if you want to use what I use, there's an updated discount link in the video's description. All right, so for every test, I include experiments with the goal of improving a couple of the weak spots, including Horvath's epigenetic age, homocysteine, DHEA sulfate, and thyroid hormones as a few examples. But I don't want to blow up the overall approach, as we saw in the last slide, that my biomarker data, for the most part, is youthful. So I'd like to improve the weak spots without messing up the rest of the approach. So what experiments did I do on that road? So for blood test number 2, remember this is test number 4, the chronological age minus biological age difference was my best ever over 33 tests at 19 and a half years younger. So as a part of that, alfalfa sprouts were a part of that story, or potentially a part of that story. I don't know if it's causative. All I can do is follow the correlations. Now for that test, before testing for test number 2, I averaged 120 grams of alfalfa sprouts per day. Whereas for the test number 3, I reduced it, and my biological age got a bit worse. It was 16.1 years younger. So for this test, to see if I could get back to the 19 and a half year reduction, I increased alfalfa sprouts up past the 120 grams per day to 147 grams per day. And that's in comparison with the last test, which was about 69 grams per day. Now, to increase that, I reduced clover sprouts. The reason clover sprouts were in the approach was to potentially impact NAD via trigonelline, which didn't work. If you saw, I don't know if I made that video yet, but it was 19 point something micromolar with doubling the clover sprout intake. So it didn't work. So out clover sprouts went, up went alfalfa sprouts. And we can see the clover sprout decrease to 30 grams from about 73 grams per day for test number 3. I also doubled chickpeas back to where they were for test number 2. And that's from 43 grams per day from about 22 grams per day. And to get that calorie increase, to keep it calorie neutral or somewhat calorie neutral, I took eggs out or reduced their intake, as I had increased eggs to try to push LDL higher for the LDL Dunedin pace experiment, I wasn't able to increase LDL, and I don't want to go higher than 5 eggs per day. And granted, I hear you in the comments saying, go even higher than 5 eggs per day. But remember, I'm trying to improve a few weak spots without blowing up the overall approach. And I think if I go higher than 5 eggs per day for now, that may start to blow up the overall approach. All right, I also increased peanut intake to 32 grams per day from 24. Now, one reason is because of tryptophan betaine. In other words, that's trimethyltryptophan. So it's tryptophan with 3 methyl groups, which could act as a potential methyl donor. At least for homocysteine, it didn't. But there's another reason why I've included peanuts into the approach or increased them, and I'm going to continue to keep them relatively high. And that's because they're a rich source of the long-chain saturated fatty acid, C24, 24-carbon saturated fatty acid called lignoceric acid. And as we'll see in an upcoming video, peanuts are a great source of that. They're a great way to increase plasma levels of that fatty acid, which has been associated with a reduced brain aging, with a younger brain age. And we all want to have a younger brain age. So peanuts and this fatty acid, lignoceric acid, I'd like to have relatively high levels. And again, assuming association equals causation, which I don't know. All I can do is keep it relatively high and hope for the best, right? All right, I also increased olives. So there's a lot of buzz online, a lot of snake oil about olive oil being the elixir, somewhat of an elixir of longevity. And that's based on studies where olive oil may be more favorable than other oils to include in the diet. But I find it hard to believe that including olive oil in high amounts, the processed food relative to the whole food olives, will be best for health. So if you're familiar with the channel, then you know that olive oil has zero role in my diet. But olives have had a very small role in my diet for a very long time. So to see if they can do anything, impact any biomarkers, I've increased olive intake, as we'll see on the next slide, from about 3 grams per day now to 23, an average of 23 grams per day. So that's about a 7x increase, and we'll see if that makes a dent on biomarkers going forward as I plan to test this hypothesis for increasing olive intake for a few tests going forward. All right, so then we can see that there were 22 foods on the left, but then 27 on the right, which means I took some stuff out. So for this test, I took out cinnamon, cloves, oats, and onion for various reasons. And because the blood test data was a bit worse for test number 3 relative to test number 4, I'm going to keep those foods back in. Granted, probably at smaller amounts going forward for test number 5 and beyond. All right, so what about the second half of the diet intake list, which is what we can see here. And we're going to compare it to test number 3 data. So I also increased serrano peppers as a source of spice, and that's because spicy foods or spicy peppers have been associated with a reduced all-cause mortality risk, so I'll likely cover that story in an upcoming video. So I basically added them every day, one small pepper. They may actually be Fresno peppers, they're the red version, but I've been logging them as serrano. I don't think Chronometer includes Fresno or dietary data for Fresno. Sometimes it doesn't have the macros and micros, sorry. So I average 10 grams per day, and that's up from about 1 gram per day. All right, what about cheat meals? So for those who are familiar with the channel, you know that I try to stick to no more than 2 cheat meals for a given period. But for this test, I'd been craving increasing intake of certain foods that I've been keeping relatively low, like coconut butter and cacao beans. So for this test, I decided to increase those amounts for a couple days. So following the blood test, immediately after the blood test, I did that. And then the day after, as if they were cheat meals. Essentially, they're not cheat meals, they're whole food. But I pay no attention or very minimal attention to macros and micros on those 2 days. So I'm basically lax with the diet, eating more of what I want relative to other days when I'm more of on a structured approach. But to sweeten it up, I did add sugar, just the simple sugar, glucose, to mixes with coconut butter and cacao beans. So that's a processed food, right? So that's technically junk. So how many calories did the sugar contribute to the 29-day period? So it's about 213 calories that came from sugar, just adding raw sugar to the 2 days of those cheat meals, which when divided by the total calorie intake for this 29-day period is 0.3% of all calories. So the diet is 99 or was 99.7% clean for test number 4. All right, so this list is ranked in grams. What about top contributors in terms of calories? And that's what we'll see here. This is the top 10 foods for average daily calorie intake for those 29 days. And this list is generated with Cronometer. If you want to track your own diet with Cronometer, there's a discount link in the video's description. So in terms of the food that provided the most calories on a daily basis, it's sardines. This shouldn't be a surprise. That's been the top food for many tests going back many years. And in terms of the other foods in this top 10 list, we can see that 9 of the 10 foods are the same as they were for test number 3. Again, I mentioned that the goal is to not blow up the system, but to make relatively small changes to improve the weak spots and not blow up the system. Now, one of those foods that changed was Brazil nuts, as I tried to increase Brazil nut intake with the goal of increasing dietary selenium to about the upper tolerable limit of 400 micrograms per day, with the goal of impacting the free T3 to free T4 ratio thyroid hormones. All right, what about macronutrients? How do they correspond to test number 4? So starting with calorie intake, average daily calorie intake was 2118, and that's actually the first test over the last 3 years where I've increased calorie intake. That's a 40 calorie per day increase, which may not seem like much, but for 21 consecutive tests, I had sequentially reduced calorie intake, purposely reduced calorie intake to see what effect it would have on biomarkers. Now I stopped that for this test and probably for the next test going forward, as my current average daily calorie intake is currently a bit above 2118 for a couple of reasons. One of them being SHBG and free testosterone, another being red blood cells and hemoglobin, which may tie into the SHBG story, and then also potentially for the free T3 to free T4 ratio, which didn't budge much with this small change, but we'll see how that goes for the next test. In terms of average daily protein intake, including the branched chain amino acids, it was about 105 grams per day, which is about 20% of calories for this test. In terms of fat intake, average daily fat intake was about 93 grams per day, which is 39% of total calories. And we can see how that compares against test number 3, which was a small increase relative to the 90 grams per day that I averaged for test number 3. And I did that on purpose, as again, I was trying to push fat and cholesterol intake higher for test number 3 to increase LDL, to test the correlation for LDL with Dunedin pace, the epigenetic pace of aging. But LDL stayed on the high end of my range. It didn't go higher. I was hoping to get it to around 95 or so. So I'm going to pause that experiment for now, because higher fat in my data, and again, I'm not anti-fat for others. In my data, for whatever reason, it's significantly correlated with an older epigenetic age, as indicated by Horvath, and higher glucose. I had one of my higher glucose readings over the past 52 tests at 98. And fat intake, for whatever reason, is significantly correlated with that in my data. So I'm going to cut it down to about 85 grams per day, and we'll see if the data improves. In terms of where the fat was coming from, we can see that I purposefully held omega-3 and omega-6 constant, as I was trying to play around with levels of saturated fat, which I reduced by a small amount, and increased monounsaturated fat. And for the next test, I'll play around with those two a bit more, further reducing saturated fat while increasing monounsaturated fat, as in my data, the correlations, and again, all correlations with diet, with blood biomarkers are on the correlations tier on Patreon. Monounsaturated is significantly correlated with more blood and other biomarkers going in the right direction than wrong relative to saturated fat. So to test that, I'm going to increase monounsaturated fat, more so coming from peanuts, and I've added macadamia nuts into the approach while cutting down coconut butter to see if what that does to the biomarkers, especially Horvath and glucose. All right, next up, carb intake. Total carbs were 259 grams per day, which may seem like a lot, but note that net carbs equals total carbs minus fiber. Average daily fiber intake for this test was 88 grams per day. So when subtracting that from total carbs, we get a net carbs of 172 grams per day. When multiplying that by 4 calories per gram, we get a net carbs of 32% of the total diet. Now, within fiber, note that a percentage of that, about 20%, is soluble, which means that it's fermented by gut bacteria. Soluble fiber is fermented by gut bacteria into short-chain fatty acids, or SCFAs. More specifically, about 180 calories from fiber is converted into fats. So that 8.5% can be added to the 39% for total fat to give net macros, as shown here. About 48% of the diet is fat, or for this test, it was fat, about 32% net carbs, and about 20% was protein. Now, within net carbs or within carbs, I track sugar intake. But more specifically with that, I track total fructose. And that's because the diet is rich in fruits and vegetables. And also, total fructose in my data is significantly correlated with more biomarkers going in the wrong direction than right. And again, those correlations and all correlations for diet with biomarkers are on the correlations tier on Patreon. Now, sucrose is half fructose. So when we divide that by 2 and add that to fructose, we get a total fructose for this test of 56 grams per day. Now, that may seem like a lot, but that's actually my lowest fructose intake since I started tracking in 2015, which was 57.5 grams per day. Now, I might be able to go a bit lower than that. It's a challenge to go lower because I'll have to cut fruit intake. In my case, fruit is very satiating, and in my opinion, or from my experience, a big approach of sticking to a diet long-term is satiety. And actually, satiety is probably a major focus for being able to be calorie restricted, which is my goal. I want to be calorie restricted and also as lean as possible. So if I'm cutting fruit intake with the goal of cutting fructose, I'm now on that very fine line of, am I satiated? And if I'm not satiated, that may lead to more calories. So I'm not trying to increase calories more than by a small amount, and on intentionally, not because I've lost quote unquote willpower, because I'm not satiated. So I think I can go a bit lower for fructose, but by a very small amount, and let's see if that makes a dent on biomarkers. All right, what about micronutrients? How do they correspond to this test? So we've got the full vitamin list here. It might be hard to see, so I'd encourage going full screen if you haven't already. Now, note that there is full RDA coverage for those who may be sleuthing and going through it one by one. Note that choline at 451 milligrams per day is less than the RDA of about 500, but Chronometer doesn't provide micronutrient data for sardines. And if you add the sardines, which provide about 70 milligrams of choline per day, I'm above that 500 or so milligram per day target for choline. But for anyone starting on this journey, that's what I would encourage. Full RDA coverage for all vitamins and minerals at the bare minimum, at the very least, and then see what clears up in the biomarkers after that. But then the big question is, and especially if you look at my data, why are so many micronutrients purposely higher than the RDA? And that's because I'm following their correlations with that panel of at least 25 biomarkers. Actually, I've expanded it to include the epigenetics and metabolomics, so it's a lot more than those 25 biomarkers for now. Now, the one that I usually highlight the most is vitamin K. And on this list, you can see it's at the bottom, and it's about 2,500 micrograms per day. Now, I didn't settle on that amount arbitrarily. For whatever reason, vitamin K in my data is significantly correlated with more biomarkers going in the right direction than wrong in terms of how they relate to aging and all-cause mortality risk. And for those who have been following this journey for a few years, vitamin K intakes in the beginning were somewhere around 1,500 micrograms per day, but I've been slowly titrating it upward to test those correlations, which have stayed positive for many tests. All right, so for a comparison and how the minerals for this test look against test number 3, I just pulled that up. And you can see if you go by each one, they're mostly in the same ballpark with the exception of 2. So we can see that total niacin intake was a bit lower for this test. The main reason being that I took out nicotinic acid for 28 of the 29 days. And then we can also see B12 is lower, and I took out supplementation of B12 to do the BCAA homocysteine experiment. Next up is mineral intake, with mineral intake for test number 4 on the left and test number 3 on the right. Now first, note that almost everything is in the same ballpark for all the minerals on the list, test number 4 versus test number 3, with the exception of selenium. Now that 60 microgram increase is only because I increased Brazil nuts for the last half for the 29-day period, but I've kept them relatively high with the goal of 400 micrograms per day for the selenium target. So for the next test, we'll see selenium at 400 micrograms per day. And I did that because selenium is required for the conversion of free T4, the thyroid hormone, thyroxine, into free T3, triiodothyronine. So to test that, I've increased selenium to see if I can get an increase for the free T3 to free T4 ratio in my data. Now, that may not work on its own. I may need to add things like coenzyme Q10. There is some published data showing that combination can improve the free T3 to free T4 ratio, but that's a story for another day. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon, where I include daily diet data, including screenshots of chronometer data for foods, macro, and micronutrients. We've also got discount links that you may be interested in, including discount links for epigenetic testing, oral microbiome composition, NAD quantification, at-home metabolomics, at-home blood testing with SciFox Health, including ApoB and GrimAge, green tea, diet tracking with Chronometer, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, so if you're interested in wearing the ConquerAging or Dietary brand, as I've got on here, that link and all of the other links will be in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.